This video should be pretty quick, but we're just going to define the characteristics of these CPAs. We know that contact B has a CPA that's closer than contact A, obviously, but we could define it based off of two different characteristics. Distance and bearing, obviously, just like we've been defining these M measurements off of distance and bearing. So we'll label that as CPA bearing and CPA range. It's just what will the contact bear when it's at its CPA, and how far will the contact be when it's at its CPA. So for contact A, and this is why when I drew the CPA line, I had it swing all the way out to the end of the compass rose here. Contact A, if you were to follow this line to its CPA, and then further, you could see it hits 104. What that means, it's a little under 104, but 104 is close enough. 104 is the CPA bearing of contact A. Then if you were to follow it with contact B, comes to here, then all the way over, gets to 148. So 148 is the CPA bearing of contact B. Now for CPA ranges, you can measure this distance here out to A. Then you could swing it over to our scale. Remember, we're using the 1-to-1 scale for this problem, but if you were using 2-to-1, that's fine as long as you stay with 2-to-1 the whole time. And we get to 2.8. 2.8 nautical miles. That is the CPA range of contact A. Now, if we do it for contact B, measure it out. It's less than a mile, so we kind of have to move it up a bit. We get 0.9. 0.9 nautical miles is the CPA range of contact B. We don't normally label it. We just have it in our heads, or we put it on a separate piece of paper because we don't need to have that written on the scope, but it's just the easiest way for you to see it. CPA bearing is not that important, but it just kind of helps you create a mental image of what's going on if you know the CPA bearing. CPA range is extremely important because that's the risk of collision. That is risk of collision, or it is what determines it. If your contact has a CPA of 7 miles, there's nothing to worry about. It's never going to get near you. It's going to at the least be 7 miles away from you. So there's never any worry. If your contact has a CPA of 0.1 miles, you're going to hit it. Maybe you'll just barely pass away from it, but you're going to get really, really close. What the CPA range matters is your captain on your ship is going to have reporting criteria and avoidance criteria where it'll vary from ship to ship, but any contact that gets within the captain's standing orders might say, or night orders might say, any contact that has a CPA of less than 2 miles, contact me about it. So just call me and tell me that that's going to happen. Any contact that has a CPA of less than half a mile, contact me and avoid it. 2 miles is acceptable as long as the captain knows, but anything within half a mile, you need to maneuver for to get it away from half a mile from you. That's why the distance of CPA is critically important. And when you're actually doing this plotting in a practical setting, you don't need to calculate your DRM. It's not that important. You don't need to calculate, you need to plot your DRM, but you don't need to measure what the angle of the DRM is. It's not that important. You don't need to measure what the angle of the CPA bearing is. It's not that important. You do need the speed of relative motion. That's going to be necessary later on. What you need the most, though, is your CPA to find what contact is going to have a close enough CPA to be a threat to you. And that's what you have to prioritize. So normally you would just set up M1 and M2 draw the line, and then immediately set up your CPA, draw it, and then measure how far away that CPA is going to be.